Good morning, my dear students. In this particular video presentation, again, we will discuss some more problems meant for class 12 of CBSE. The question goes like this. It's a problem on linear programming problem, LPP, linear programming problem, LPP. Minimize p is equal to 5x plus 4y subject to the constraints x greater than or equal to 0, y greater than or equal to 0, x plus y greater than or equal to 2, x plus 2y greater than or equal to 3. Just see, this is the question. This is the question. Just read the question if you want. Let me just initially draw the straight lines anyway. X plus y is equal to 2 is a straight line passing through 2 comma 0, 0 comma 2. Therefore, this is my x plus y is equal to 2. Now, x plus 2y is equal to 3 is a straight line passing through 3 comma 0. When y is 0, x is 3, and when x is 0, y is 1.5. This will be 1.5. Okay, this is x plus 2y is equal to 3. This is how the diagram is drawn inside. And just take the point where the line intersects the x-axis, where the line intersects the y-axis, and then draw accordingly. It will be easier for you to find out. It will be easier for you to find out. This is my y-axis. Okay. Now I'll actually I'm not going to write the explanation about x plus y is equal to x plus y 2y is equal to 3. I have explained y equal to 0 means x is 2, x is 0 means y is 2. Therefore, it passes through 2 comma 0, 0 comma 2, and here when y is 0, x is 3. It passes through 3 comma 0, and x is 0, y is 1.5. Okay, this is my point where it passes. Anyway, doesn't matter. Now 0 comma 0 does not satisfy. Just how to identify the region, just see here. I am explaining that part. X plus y greater than or equal to 2, x plus 2y greater than or equal to 3 as 0 greater than or equal to 2, 0 greater than or equal to 3 or meaningless. Okay, now x greater than or equal to 0, y greater than or equal to 0 implies region lies in the first quadrant. Therefore, let me club everything. Region lies in the first quadrant. And to the sides of both the lines. X plus y is equal to 2. X plus 2y is equal to 3, where 0 comma 0 does not lie. If 0 0 satisfies, it will lie to the side where 0 0 lies. 0 0 does not satisfy, it will lie to the side where 0 0 does not lie. Therefore, shaded unbounded region. This is my region. Shaded unbounded region is the required region with vertices. What are the vertices I will get? This is A 3 comma 0, B 1 comma 1. This point will be B 1 comma 1, and of course C 0 comma 2. These are the three vertices of the given region. Therefore, I'll just make the tabular column vertices, then value of the quantity p is equal to 5x plus 4y. Let me just see what happens. P is equal to 5x plus 4y is we call it as objective function. At a 3 comma 0 it is 15. At b 1 comma 1 it is 9. At C 0 comma 2 it is 8. This is my minimum value. But remember carefully, since the region is unbounded, we draw 5x plus 4y less than 8. Let me just draw. Let me just see what happens. This passes through when y is 0, x is 1.6, somewhere else here. Let me just plot exactly. This is somewhere else here 1.6. And of course, when x is 0, y is 2, it passes through 2. Therefore, I'll draw dotted line like this. Dotted line like this. Sorry. Okay, this portion won't be there. I'll draw dotted lines as the line 5x plus 4y equal to 8. This portion won't be there. Sorry. I won't be having points over there. It will be the line like this. Okay. This is my 5x plus 4y is equal to 8. Okay, I'll be able to identify none of the points of the line, I should be able to write like this. I should write, it's very important, none of the points of the feasible region lie, what is it exactly? Lie in 5x plus 4y less than 8. If any such point lies there I'll get the minimum value. Therefore, minimum is obtained except 0, 2 anyway. Except 0, 2 you write. Obtained only at 0, 2. Minimum value is 8. Minimum value is 8. For any unbounded region, I am supposed to give such an explanation. I have to give such an explanation. When x is 0, y is 2 or at 0, 2, minimum value is 8. Let me just explain once again. X plus y equal to 2 passes through 2, 0, 0, 2. Okay, this is my x plus y is equal to 2. This is my x plus y is equal to 2. Okay, then x plus 2y equal to 3 passes through 3, 0 and 0, 1.5. Now 0, 0 does not satisfy both the inequations. And x is positive, y is positive means region lies in the first quadrant. The region is the first quadrant as well as to the sides of both the lines where 0, 0 does not lie. This side of the line. This unbounded region is the common feasible region. You can write feasible here again. There are three vertices A 3, 0, B 1, 1. This point, while you draw it out in graph paper, you will be able to get it automatically 1, 1. 1 plus 1 is 2, 1 plus 2 is 3. 1, 1 is the common point. That's correct. C 0, 2. Substitute these values in the objective function. I get 15, 5 3s are 15, 5 plus 4 9, 4 2s are 8. Out of which the minimum value is 8. Since the region is unbounded, we draw 5x plus 4y less than 8. And it passes through, of course, 1.6, 0 and 0, 2. When x is 0, y is 2. When y is 0, x is 8 by 5 means 1.6. 1, 5, 5, remainder 3. 6 5s are 30. It's correct, 1.6. And none of the points in the feasible region lies in 5x plus 4y less than 8 except 0, 2. If any other point is there in the feasible region, in this particular region, from the feasible region, that will be counted as the minimum point. That will be the minimum value we'll think over normally. Normally it won't be so. You will be able to write only like, you will be expected to write only like this. None of the points of the region 5x plus 4y less than 8 lies in the feasible region except the point 0, 2. The minimum value is only at 0, 2 and minimum value is simply 8. For any unbounded region, remember this particular point, how to draw the particular line 5x plus 4y equal to 8 and find the region 5x plus 4y less than 8, and then you explain none of the points of the region lies in the feasible of 5x plus 4y less than 8 lies in the feasible region. Better write and give the conclusion as it is where you have earlier as your minimum value. Now next problem goes like this. Find the area of the parallelogram with A vector is equal to I plus 2j plus k, B vector equal to I minus j plus 5k as adjacent sides. This is my A vector, this is my B vector. The application of cross product tells you mod A cross B is equal to area of parallelogram with A vector, B vector as adjacent sides. Remember carefully. Let me try to find A cross B. Determinant ijk. Second row components of A 1, 2, 1. Third row components of B 1, minus 1, 5. I cap into 10 plus 1 minus j cap into 5 minus 1 plus k cap into minus 1 minus 2, which is 11i minus 4j minus 3k. Now area of parallelogram is equal to mod A cross B, which is root of 121 plus 16 plus 9, root 146 square units. This much square units. If A vector, B vector are diagonal, this is my A vector, this is my B vector, application is half mod A cross B. The proof of which I gave in one of the videos long back. I am not going to go into the proof of this. Half into A mod A cross B will be the formula. If A vector, B vector are adjacent sides, mod A cross B is the formula of area of parallelogram. A vector, B vector adjacent sides of the parallelogram. If those A vector, B vector are diagonals of the parallelogram, half mod A cross B is the formula. The proof of which I gave long back in one of the videos anyway. Repeat A cross B, determinant ijk, second row components of A 1 to 1, third row components of B 1 minus 1 5, I cap into 10 plus 1 minus j cap into 5 minus 1 plus k cap into minus 1 minus 2, 11 I cap minus 4 j cap minus 3 k cap. Area of parallelogram is mod A cross B, root of 121 plus 16 plus 9, root of 146 square units. If I am adding one more point over here, if A vector, B vector are diagonals of a parallelogram, half mod A cross B is the application. Remember carefully. The next one is A is 1, 2, 3. Just I'll add up one more problem. I'll finish it off in just 2 minutes. Okay. Capital A has elements 1, 2, 3. Relation R on A is given by, relation R on A is given by, R is equal to, let me just write, A is 1, 2, 3. R on A is given by 1, 1, 3, 2, 2, 1. Okay, check for reflexive symmetric transitive nature of R on A. This is the question, just see. Check for reflexive symmetric transitive nature of R on A. By reflexive nature, we mean each element should be related to itself. Here only 1, 1 is there. Therefore, 2, 2, 3, 3, not an element of R. Therefore, R is not reflexive. To negate the statement, always we should think of an example. Okay, now 3, 2 element of R. But the reverse way, 2, 3, not an element of R. Therefore, R is not symmetric. R is not symmetric. Then 3, 2 is there, 2, 1 element of R. But 3, 1 not an element of R. Therefore, R is not transitive. Therefore, R is neither reflexive nor symmetric nor transitive. Let me just repeat. For reflexive nature, each element should be related to itself. Only 1, 1 is there. 2, 2, 3, 3 are not there in R. Therefore, R is not reflexive. 3, 2 is there, but reverse way 2, 3 is not there in R. R is not symmetric. 3, 2, 2, 1 are there, but 3, 1 is not there. Therefore, R is not transitive. Therefore, it is neither reflexive nor symmetric nor transitive. Such a problem may also be may be given in your board examination. Think over the rule behind that. If the values are changed, you just do accordingly. Okay. I'll just check for the calculation. If there is any error, I'll correct it out. Otherwise, I'll upload as it is, as usual. Thank you, students, for patient watching.